looking at this last one, we have the summation from n equals 1 to infinity of n to the nth power divided by n factorial. So this one is a little bit different than the other ones. We're still going to use the ratio test here. We just may need some other tricks here to kind of help us out. So we have the limit as n approaches infinity of the absolute value of, on the bottom we always have a sub n, so we have n to the n divided by n factorial. All of our other pieces we have n plus 1 instead of n, so we have n plus 1 to the n plus 1 and n plus 1 factorial. Okay, so same thing always, we're going to take this and change it into a singular fraction instead of complex fractions. So I have n plus 1 to the n plus 1 divided by n plus 1 factorial times, and if we flip it, n factorial over n to the n. So now what we're going to do is simplify what we can. The real thing here that we can simplify is our n factorials and n plus 1 factorial. So reminding that n factorial is n times n minus 1 times n minus 2 times n minus 3, and so on forever until we get to 2 times 1. N plus 1 factorial is equal to n plus 1 times n minus 1 times n minus 2, and so on until we get to 2 times 1. So if we take these two and kind of rework them, n plus 1 factorial is the same thing as saying n plus 1 times n factorial. So we're going to use that substitution to kind of help us out here. So we have n plus 1 to the n plus 1 divided by n plus 1. Ooh, we'll flip those around, so we'll do n to the n times n factorial divided by n plus 1 times n factorial. We have an n factorial on top and bottom, so we're going to go ahead and simplify. If I do that, we're going to have an n plus 1. So if I were to now look at this, we have the limit as n approaches infinity of, well, I have an n plus 1 here, I have an n plus 1 up here. So what we're going to do is we're going to cancel out. We're going to divide an n plus 1 from here and an n plus 1 from here. That's going to cancel out to be 1. But that does reduce this exponent because we're taking away one of those n plus 1s. So we have instead n plus 1 to the n power times 1 divided by n to the n power. So the other way that I can rewrite this is the limit as n approaches infinity of the absolute value of n plus 1 divided by n, all raised to the nth power. Because they're being raised to the same power, I can kind of split that up a little bit. This is actually a really special limit because this limit is how we approximate e. So this limit actually equals e. So now what we need to decide, e and its relationship to 1. Well, I know e is bigger than 1, so our series is going to diverge. So this last part here is what we call eyeball tests versus work tests. Work test being we have to do work. For instance, the ratio test is a work test because you have to do work to figure out what's going on with it. Versus eyeball tests where we can kind of look at a series and we can decide what's going on with it. So some of our eyeball tests, geometric series are part of that eyeball test. Along with that P series, which means the harmonic series and the alternating harmonic. So the harmonic series, the P series, the nth term test, and alternating series. These are all tests that we can kind of look at a series and make a decision without having to do a large amount of work. On the other hand, work series or work tests, we have the integral test. You have to have a bunch of prerequisites for the integral test, and then you also have to do an improper integral. You have the comparison tests, so direct comparison and the limit comparison are both work tests because you have to pick a function, then you have to compare it to another function, and depending on what happens once you're done with that comparison, which is generally with algebra, you'll get a decision, and then of course the ratio test. We generally hope to have one of the eyeball tests, or we use one of the eyeball test series to help us with a work test. So like I said, this is the last of the tests that we're going to be doing, so now we're going to be using those tests for different things. And then we get a little bit further out from that, but still in the series realm.